Hollywood movies and documentaries have shown people busy living on other worlds. But the movies never show how the moon bases were built. The lightweight surface manipulation system, designed, built, and being tested at the NASA Langley Research Center, is taking the first step to answering that question. Construction sites on Earth share two features. They have access to a large labor force and a large amount of existing infrastructure, machines, and tools. But when it comes to exploring, working on and colonizing other planets, we are faced with extremely harsh and empty environments. In order to work on and settle these distant planets, all of the infrastructure needed to live there will most likely have to be built before humans arrive. The infrastructure and other payloads arriving at the moon on future missions will have a wide range of masses, sizes, and packaging schemes. Since the cost to land any mass on the lunar surface is very high, the amount of infrastructure and the number of devices that can be dedicated to surface operations is likely to be limited. In contrast to Earth-based construction, where a wide variety of dedicated single-purpose devices are used, lunar missions will only have what we bring there, so the devices need to be versatile and multi-purposed. These multi-purpose devices will have the added benefit of significantly reducing operating expenses over the moon base's lifetime. The Lightweight Surface Manipulation System, or LSMS, is a lunar surface robotic crane that solves one of the many challenges that will be faced by our astronauts. How do we unload heavy, large, and sometimes unwieldy payloads and cargo from the lander and assemble them into a working lunar base? The LSMS is designed to be an autonomous robotic device that can perform most of its many functions without human participation, both before and after crews arrive at the base. The robotic crane has 3 degrees of freedom, allowing it to move much like a human. Waist rotation at the base, shoulder rotation at the top of the king post, and elbow rotation at the midspan of the boom where the arm and forearm links are joined. With its 3 links, each of which are 3.75 meters long when standing on the moon, the crane is capable of reaching over 9 meters above its surface. The lifting link can vary the length of its working section, acting like a hoist, and is used to unload all of the items, both heavy and light, from an unmanned cargo lander. Many tools which are grabbed by the quick change device at the LSMS wrist are being developed at NASA Langley for the LSMS Toolbox. The long-reach LSMS arm moves and positions these tools wherever the work needs to be done. The Payload lifting link is engineered to capture hooks that are located on top of cargo. The hooks are designed to precisely fit within the lifting bar located at the end of the link. Conical discs on the lifting bar guide the operation and ensure that the hook is acquired and engaged every time. Structures prefabricated on Earth, prepackaged cargo, and other payloads can be easily lifted and placed on the moon's surface. But before these items are placed there, the LSMS could use one of its many tools, the regolith scoop, to remove obstacles like rocks and boulders and level the site. A special welding tool has also been developed which provides another means for constructing and assembling infrastructure such as shelters. In the future, individual habitat modules might be designed so that they could be welded together to provide a permanent airtight seal, thereby creating much larger units with plenty of room needed for research and living. The Forklift Tool provides another way to unload critical supplies safely and efficiently. It works just the way you would expect a forklift to work on Earth, only there is no human operator. The LSMS is a completely new concept for a long-reach manipulator invented specifically for doing work on other planets. The LSMS links and cables maintain a series of structurally stiff and strong triangular shapes throughout its full range of motion. Along the tension actuation cables are a series of pins that automatically engage and disengage from special grooves located at the ends of the spreaders. The LSMS derives its high strength and stiffness by always maintaining this simple geometry of triangles. The capability to lift cargo on Earth weighing 150 kilograms would translate to lifting 500 kilograms on Mars and 1,000 kilograms on the Moon. So items that might be too heavy for the crane to pick up on Earth are easily lifted and manipulated on our nearest celestial neighbors. All of these innovative features enable the lunar crane to be an efficient and effective working machine on the Moon, a necessary assistant to the astronauts who will one day return there. Before, during, and after America returns to the Moon, the lightweight surface manipulation system will help create and build the infrastructure needed for astronauts to live, work, and explore there. This new robot will likely prove to be indispensable for making their lives easier on a distant, hostile world.